very similar. So the first thing is whenever we're solving an equation with a square root, and especially if our variable right here is underneath the square root, the first thing you're doing is you're trying to get the radical alone. So anything extra like that minus 18, we want to get that algebraically. Let's move that over to the other side. We want to get that radical alone on one side. And you can still kind of follow your same rules. You're going to kind of work backwards through the order of operations to start to get that radical alone. So here I have this minus 18. What I would do is I would add 18 to the other side. So I'm just going to show that step there. Okay, there it is. So then I'm going to have the square root of 8x plus 17 is equal to, and then negative 9 plus 18 is going to equal 9. Now if you haven't watched the video yet, or if you kind of forgot, you maybe are already kind of thinking about what to do next. Now, algebra uses inverse operations, so like opposite operations. If you have a square root, you're thinking, what is the opposite of doing a square root? Well, the opposite of doing a square root is squaring. So we're going to take and we're going to square both sides. That's going to cancel out my root. So if you do a square root and then you turn right around and square it, it's going to cancel out whatever that square root did. And now you're just left with that expression underneath, 8x plus 17. And that's going to equal now to 81. Then you're just finishing your algebra. We'll subtract 17. Subtract 17. We're going to get 8x is equal to 64. Divide both sides by 8. We'll get x is equal to 8. And then we should be able to plug that in. X is equal to 8. And there's our result. And they're going to show us the steps as well. So as you're practicing that, they'll show us those steps. And take a second, even if you get it right, just kind of checking their work, checking to see how that process went. So when you're solving a radical equation, your first job is to get that radical alone, because we can't undo the radical until we get that radical alone. So we have 10 of those to practice, just kind of practicing your algebra. Our next section, we're going to start looking at solving radical equations with a rational exponent. Let me get this cut off here. Now, rational exponent is an exponent that is a fraction. That's what we were talking about in sections 1 through 4 in the first half of chapter 6. But really what a rational exponent is, it's really a radical. So if I look at this, I have a 1/2. This really means I'm talking about the square root of x plus 1. So even though it says 1/2, a power to 1/2, I'm kind of in my head thinking, okay, that's a square root of x plus 1 happening right there, because remember the denominator is going to end up being the index of my radical. So I'm going to use the same strategy as before, except now instead of getting the radical alone, I'm getting this part right here that has the rational exponent alone. So I'm going to use algebra to get this part alone. And with algebra, you always start by undoing your adding or subtracting if it's there. So there we're going to undo a minus 8. So I'm going to add 8 to both sides, which is going to give me this, 5 times x plus 1 to the 1/2 equals 15. Then I'm going to divide both sides by 5. I'm going to get x plus 1 to the 1/2 equals 3. So I divided both sides by 5. There's what I'm left with. Now, how to undo a 1/2 power? Same idea. We're going to raise both sides to the second power. So even though I have a rational exponent, I'm still kind of thinking of that. That's going to be a square root of x plus 1. So to undo a square root, I can take and I can raise it to the second power. Another way you can think of it is it's a power to a power. So if I'm raising something to the 1/2 and then to the second, what that causes me to do is take 1/2 times 2, which cancels out that exponent basically. It makes it 1, which is what I want. I want to get that x plus 1 alone, get rid of that 1/2 power. So really you're just raising each side to the reciprocal of your exponent. So I'm raising each side to the reciprocal of 1/2, which is 2, because 1/2 times 2, anytime you multiply reciprocals, you get 1, which is what we want. So now we're gone down to this, where x plus 1 equals 9, and x is going to equal then 8. So there would be my final solution. X is going to equal to 8. We'll get back to here and should get our answer there. So there, it doesn't have the work shown out, but you can check work as you go. If you don't want to put it in to possibly get it wrong, you can put it back into the original equation, see what your results are. But anyway, that will kind of get us started with section 6.5. So even though we have those rational exponents, we're thinking of those as radicals and all that extra stuff around it. We want to get rid of all that stuff first, then get that rational exponent isolated, and then you can raise each side to the reciprocal. But we're at 10:02. Sorry, went a little over today. I will be sticking around till 10:25. If you're ready to work on your own, have a great day. Welcome back from break. I recorded this. I'll post this on our Schoology page.